While you were taking your grade level acuity, I noticed that there were a couple concepts that you just needed a little bit of a review on. The first is box and whisker plots. You don't have to take any notes on this. This is just a quick review session. I'm going to go fairly quickly, so pause it if you need to. Okay, box and whisker plot just shows how data is spread apart. Okay, the lower extreme is just the lowest value of my data set. That makes my upper extreme highest value of my data set. Okay, and then my first quartile is the median, or the middle, of my lower half of the data. My second quartile is just the median of the overall data set, the middle. And then the third quartile is the median, or the middle, of the upper half of the data set. You'll notice the word quartile kind of sounds like quarter. When you place these on your box and whisker plot, it actually divides the data into 4 quarters, 4 sections. Here's some steps to make a box and whisker plot. If you would like to read through these, if I unblock it here, if you'd like to read through these, go ahead and pause it. I'll scroll just a little bit so you can see the whole list, but I'm not going to read through all these. I'm just going to do an example. Okay, here's our example. Use the data to make a box and whisker plot of the heights of basketball players in inches, and then answer some questions. Okay, to be able to make a box and whisker plot, you first of all need to put your data in order from least to greatest, so we're going to do that. Okay, make a number line. We need to go a little bit below 67 is our lowest number, so we'll go with 66, and then maybe go by 2s, and then we have to go a little bit above 85, so let's go up to 86. Okay. First of all, we're going to find our lowest data value, 67. We're going to put a dot above where 67 would be on the number line. We're going to find our highest data value, which is 85. We're going to put a dot above where 85 would be on the number line. Next thing you're going to do is find the median. The median of the 8 values would be halfway here between the 2 middle numbers, which would be 74. Again, if you can't do that in your head, add the 2 numbers together, divide by 2. So 74, we're going to put a line above 74. That's our second quartile, our very middle. Okay, now to find the other 2 quartiles, we're going to find the middle of the lower half of the data. So the lower half of the data here, the middle of those 2 is 68. So go ahead and put a little dash above 68. Okay, and then we're going to find the middle of the upper half of the data. The middle here would be 78. So we're going to put a dash above 78. Connect the dashes. That makes your box. Draw some lines out to your extremes, and that makes the whiskers. And that's box and whisker plot. Now, by looking at the box and whisker plot without looking at the list of data, you can answer some questions. You can answer the largest data value. That's the upper extreme, so that would be 85. You can find the range of the data values. That's where we take the highest number, subtract the lowest number. That gives us the range. And then the last question is one of the most important ones. It asks about what fraction the values are greater than 74. Well, as I said before, quartiles divide the data into quarters. So what that means is that this first area right here, this tiny little area here, represents 25% of the data. A fourth of the data is between 67 and 68. This next section here, 25% of the data, that means 25% of the data falls between 68 and 74. Next section, 25% of the data falls between 74 and 78. And then the next section, 25% of the data falls between 78 and 85. So what's fraction of values are greater than 74? Let's find 74. Greater than 74 is to the right, so that's 25, 50%. 50% is a fraction is 1/2. Here's another example of a box and whisker plot already made. Take a moment, see if you can go through and answer these questions. So the first question asks, what's the upper extreme? If you said 100, you are correct. 100 is the highest number, that's the upper extreme. The second question is about what percent of the values are less than or equal to 87. This is where we use those quartiles. We tell ourselves this part has 25% of the data. This part here is 25%. This part here is 25%. And this last part here is 25%. Okay, so less than or equal to 87. Let's find 87. Go to the left. That's 25, 50, 75%. Next question about what fraction of the values are between 51 and 87. So find 51, find 87, and if you look there, we see 25, 50%, and as a fraction, that is 1/2. And then the last question is, what's the median of the data? The median is always your second quartile, which is in the middle of your box, that line in the middle of the box. And that line in the middle of the box here is about at, I would say, 68. So that would be the median of your data set. Okay, one last thing, we're going to do a quick review of stem and leaf plots. Okay, a stem and leaf plot here shows the test scores of students in a math class. Okay, to find the median of the data, there's a couple different things you can do. We can list out all of the numbers. So it's for a review. The stem gives you the first number, and the leaves will give you the second number. So that's 53. These numbers are all in the 60s, so that's 65, 68, 69, 70, 72, and so on. Now this is really big. We don't want to have to list out every single piece of data. So another thing we can do is we can count how many numbers there are. You count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There are 15 different numbers that you're going to have. So to find the middle, we divide by 2. And that means it's going to be halfway between the 7th and number on both ends. Okay? So let's start counting backwards from the top. So 1, 2, 3, 4, 5, 6, 7. Okay? Let's start counting up from the bottom. 1, 2, 3, 4, 5, 6, 7. And if you'll notice, between those two sevens, the only number left here is that 9. So that means our middle number is going to be 79. Again, if you don't get doing it that way, you can finish listing out all your data and find the median, the middle number that way. Okay, what's the mode of the data? You're looking for the number you see most often in a row. If you look at the top row with the 90s, there's no duplicates. The 80s, I don't see any duplicates. The 70s, I see some 2s. 60s, no duplicates. 50s, no duplicates. So the number I see most often is in the 70s, and it's the 2. So the mode would be 72. To find the range, we take the highest number minus the lowest number. Our highest number is in the 90s, it's 94. Our lowest number is in the 50s, it's 53. And if we subtract that, we get 41. That would be the range of our data set. All right,